Today we're going to be talking about rational expression equations, which are equations that have fractions on one or both sides that we need to take care of. The general process is to get a least common denominator for the whole problem. That's the left and the right side need to have the same denominator. And then, since the denominators are the same, that means the numerators should also be the same. So we can cross off the denominators and just solve the remaining numerator equation. So the first example we have is written up here. And what we want to do is get a least common denominator for all three fractions that are involved in this. So you can see that if I multiply the second fraction by a 2p over 2p, that would get me a 6p squared like the first one. And I can multiply the last fraction by 2 over 2, which would also get me a 6p squared. And now we have a least common denominator. Make sure that you distribute the 2 to the top. That is 4p minus 8. That is very important. Now, since all the denominators are the same, we can cross them off and just look at the numerator equation, which would be p plus 4 equals 2p plus 4p minus 8. And this equation we can solve like any normal equation. First thing you want to do is combine your like terms. So we say 2p plus 4p gets me 6p. And then we want to start solving this equation by subtracting or adding things to both sides. I'm going to start by subtracting the 4 from both sides, which will get me this negative 12. And then I'm going to subtract the 6p from both sides, which will get me a negative 5p. Finally, we want to divide both sides by a negative 5 to get the p by itself, which would get me my final answer of p is equal to 2/5. Let's look at a second example that's slightly more difficult. We want to take this and we want to get a least common denominator. So we want to look at the second fraction here and see how that denominator is different from the original. And if I get a p on the second fraction here, on top and bottom, that would get me a least common denominator of p squared plus 4p. And that would be the same in all three fractions. Now, since all the denominators are the same, we can cross them off and just look at the remaining numerator equation, which would be 1 plus 3p equals 5p squared plus 20p plus 15, which I have written down here. This is a quadratic equation, so we're going to have to solve the quadratic equation like we would any quadratic equation. So the first step would be to get the left side equal to 0 so that we have everything on the right side. You can see that I subtracted 1 from the 15 to get 14, and I subtracted 3p from the 20 to get 17p. I'm not going to go through all the individual subtraction and addition steps. Now this is a quadratic equation that you could solve by either factoring or using the quadratic formula, and I chose to do factoring. So after I factor this out, I would get p plus 2 equals 5p plus 7. And since these are both set equal to 0, we can set each one of them equal to 0 and get my two answers of p equals negative 2 and negative 7/5.